For those of us that are of age, we would remember the 2005 floods. And then for the younger persons, you remember the 2021 flood that we had recently, in which um, a large portion of the country was flooded for weeks. Now, I don't have data for that or statistics for that, but these were the statistics for the 2005 flood, that we lost 34 lives and lost almost 60% of our GDP, which is quite a lot. And thankfully now we have oil and gas, and so it might be easy to recoup that. But think back in 2005, to lose 60% of your GDP was not a look good. But it's also a paradox, because there is also a lot more to lose now, right? So it's one thing to say that we can recoup it, but there's also a lot more to lose, a lot more development, a lot more infrastructure. And so it's quite important that we start to investigate and implement the right tools to get ahead of the curve. One of the major issues back then and still today is there is a lack of data and expertise to develop a complex system. One that we may see in, developing countries, or first world countries as they're called. And even if we were to get the funding to develop it, there is this lack of expertise on how to properly treat it, and how to properly interpret the outputs, the inputs, and the overall analysis. So the objective back then was to, in during the masters, was to just look at a simple early warning system using some rainfall thresholds and numerical weather predictions. But for the sake of this conversation, it's not about the thresholds, but improving numerical weather predictions. And over the next few slides, I will show exactly why it's important. All right. So Hydromet currently uses a 15 km resolution based on how the model was initially set up. And I must say that I would have worked at Hydromet. I started my master's while working at Hydromet, and this is what led me to investigate this system to begin with. So it's a 15 km resolution, right? And we want to focus on Georgetown. And so we're going to crop into Georgetown and focus on that area. Now, for an event on May 14, 2015, over 48 hours, 66.4 mm of rain was recorded. So this was taken from actual Hydromet rain gauge data. If we look at the key at the bottom, we will see that 66.4 should be somewhere in the lime green to orange area. If we look at the current configuration at the top left, it did okay. And the WRF has a tropical scheme, which of course was investigated since it's tropical and we're in the tropics. That scheme significantly underestimated, under forecast the rainfall for us. Maybe it works for other areas in the tropics, but at least for Guyana, it appears to be not the best for us. Then we can see other schemes performing quite well, others over forecasting, but we can see B to the far right, top right, doing okay. We can see D also doing okay, and then we can see F. Similarly, for another event, or unfortunately in this case, because in the previous event the current one did okay, the current configuration parameter scheme did okay, we can see that for this one 133.9 mm was recorded. If we look at the legend, we'll be looking for between this pink to purple dark blue area, and the current configuration, the current parameter scheme was far off, under forecasting this event over the 48 hours. But we can see that B, D, and F did much better, right? So B, D, and F represents a matrix or combination of different parameters. I'm not going to show them or explain what they are, because that's on the technical background. So the point of this is just to show how much of a difference it makes in terms of what the model gives you and how it can affect. So imagine over 48 hours recording 133 mm of rain, but 48 hours ahead, you had, according to this forecast, maybe about 50 to 60 mm of rain falling. So definitely changing to like B, D, or F would be better for Guyana. Look at the third event, 2017 January, 97.8. Again, the current scheme of parameters on the forecasting. So we have a bit of lighter green blues, so probably between 30 to 50. Again, we have B, D, and F performing quite okay.